Well, howdy. I'm not sure where I left off last. This is a new day, and so I'm picking this back up today. I've gone through and I've checked all the values on the resistors. Resistors are just fine. A lot of them are pretty much right where they belong. Some of them are a little plus or minus, but they all are within tolerance. Keep in mind I did check with them soldered in place. So I'm giving a little allowance that, we should probably be just fine. Went through and checked the transistors, also in place, and I didn't see any issues noted. And this big capacitor down here that I couldn't get out in the schematic right here is the capacitor in question. So my next step is going to go through the board and I'm going to pull all the electrolytic capacitors. As I stated, there is not that many. We've got 2, 3, 4. We got about 4, maybe 5 electrolytics here and done. And then when that's done, I'll go ahead and run through with a voltometer and I'll check the capacitors and others and see if I see any other issues. I almost forgot to mention one other step that I need to do is go through the display board. I want to check that one digit that is having issues, that's not displaying fully. I'm going to check the display itself, and you can see here I have my benchtop power supply set to 15 milliamps for current. I'm suspecting it is the display, but I'll just double check anyway. I had to step away from the computer for a while, had to go somewhere, but I'm back, and I think the last thing that I made mention was I was going to test out the LED to see how it responds, to confirm that yes, it is the LED and not the decoder or resistor or the transistor or anything else that comes into play with it. Put a little light on the subject. These chips down here, these are the decoder chips for the display. Power comes in, and when it receives a signal or a command, it says, hey, light this digit over here, or even that digit, or all the digits. Well, this will do its job and do just that, illuminate each digit in there. These resistors here, they act as a current limiting resistor, and the transistors come into play with the network as well. So when you're dealing with the LEDs, yes, you're going to have resistors, you're going to have transistors. You may not have the decoder because you could probably do this manually your own self. A lot easier doing it with the chip. So how did I test this? Well, let me show you what I did. On the back of the board, let me zoom in. On the back of the board, I soldered a pin to the board. Now this pin, all this is if you've ever cut a leg off of a resistor, capacitor, or something like that, and you threw away the excess, here's a good reason why you don't throw away the good excess. You keep that pin for goofy little jobs like this. You solder it on, and you connect your probe to this. Now the way how these LED, 7-segment LEDs work is the center pins, pin number 3 on either opposing side, is your positive leg, and the other legs of the LED are your negative. So when you connect power, you're taking that leg to ground. So I know this is probably going to be hard for me to do because I'm at this awkward angle, but connect my positive leg and take my negative and this is going to be really challenging for me. Of course, I'm on the actual digit next to it. And you just do that. You connect it to that. And then once you take it to ground, the LED will illuminate. Let me see if I can get it in place and I could show you the other side. And here with that method you could see that that digit is illuminated. Now before I left I made comment that I set the power supply to 15 milliamp draw, and that's because I forget the exact number. These draw about, I think, 18 milliamps or thereabout. So you want to ensure that when you set up your power supply, your power source, that that's exactly what you do. You don't shove in tons and tons of power into that, or it's going to blow it up, fry it. Voltage wise, now I know it looked like there was proper voltage going through the LED and illuminating just fine on your screen. In the camera, yes, it was illuminated just fine. However, in person, it was just barely illuminated. Again, working with the thesis of don't blow it up. Just shove enough voltage in there to make it illuminate. And for those that are familiar with that tone, you know that was eBay calling. Something's going to expire in 15 minutes. What do? Keep talking on the video or go look at what's going to expire in 15 minutes? I know, let's hurry up the video. So again, you don't want to shove in tons of voltage, fry your component. You just work with just the bare necessity and let it tell you the story. In a working environment, yes, and you're going to want to set that where it's going to be appropriate. But for testing purposes, as you see, I've got it set for 2 volts at about 15 milliamps. How to do this with your power supply? That's a very good question. You're going to need to know how to operate your power supply. On my power supply, you just simply take, as soon as I find the camera, you take the negative probe, the positive probe, you dead short them. And once that happens, you adjust your button right here to go from milliamps to amps, and then you adjust your current accordingly. For your power supply, you definitely want to assault the owner's manual. If you don't have an owner's manual, contact the manufacturer. If it's an older device that no more information is available, it's very plausible, you know, your device may not have this kind of technology to it. I've checked out that LED and I have confirmed that yes, it is the LED that is out, and the other components are just fine, as I found in my earlier test. The only thing that would have been next was to check the decoder to see if I had any output on that. And the way one could do that, you could do that probably with your voltometer, put it on volts. Of course, you're going to need to grab the data sheet for the device and find out what pin does what. And then take your readings from there on your voltmeter. Another way you could have done it is hooked it up to your oscilloscope and watched for signal out there. Would need to have that either in circuit or hook up your positive and negative ground, but at that you're not going to get a true statement, because you really would need this in circuit, test it, put it on frequency where this is all illuminated, and then test to ensure each leg is corresponding the way it should. And when I say leg per digit, that's exactly what it is. Those digits are numbered A, B, C, D, E, etc. And each one of these pins, you're going to have your voltage in, voltage out. The other pins are going to correlate to your A, B, C, D, etc. And that's why it would be great to have this inboard to have all that illuminated, so you could test, ensure you have voltage coming out. And that's how you would test that. You could also have a logic analyzer, which is a big snazzy machine that you would connect to this, look at your scope, and it would, big convoluted aspect. The easiest way, if you don't have anything other than a voltmeter, stab this thing in line, grab the data sheet, look at your voltages. It's going to be a high, a low, and that's basically how you're going to know whether or not those legs are working. I have the capacitors replaced. Got these two big ones right here, and then we have another one right here, and lastly right here in the back. Believe it or not, that is all the electrolytic capacitors this thing has. That is crazy. Outside of the one in the rear, which, as I stated earlier, has been ordered today and will not be replaced until I get the LED displays and I swap that out. Here is the bad capacitor. So what I'm going to do is I'm going to take this little device and we're going to hook it up and see what the capacitor reads. Because I know there's probably many of you, like me, interested in what it reads. And there you go. 1.4% loss. It's reading it as 138 or 1381 ohm at 0.09 ohms. So this one here is the same size. It's 1000 microfarads. Almost said 1000 volts at 35 volts. Well, that's still usable. Let's go ahead and do these other two. So this here is a 100 microfarad, 16 volts. Yeah. Alright, so this next one here is 10 microfarad at 15 volts. Try to hold this where they're glaring. Oh yeah. That one might not be very well to use. What do you think? Look at that, 3.2 ohms. Alright, let's go ahead and get rid of the elephant in the room, shall we? Let me get you center. There we go. We're going to open up this heater box. Well, managed to get one out. See, they're double wrapped. Oh. Okay. That's nice and glued. I don't think I'm going to mess with it since this is styrofoam. If I can find a picture of what it looks like on the inside, I will.
So let's look at the heater now. Normally when you open this up, there's a styrofoam box around it, which is the oven, or creates the oven atmosphere. And all it is two ceramic resistors. If you look in here, you'll see two diodes. They're the sensors, and then obviously your crystal in the center. So as the heater circuit heats these up, these shut it on and off. So that's what's in there.
The next thing to do is reassemble. There's nothing else we can do until the other parts come in. We'll reassemble and we'll test it out and see if it works any better. Oh, I lied. One other thing I do need to do. Clean these buttons right up in here, the push buttons from the front panel. Get that all cleaned and lubricated, and then reassemble. And here's a tighter look at the close-up look of the buttons that I need to clean.